This video is about problem solving with integrations. So let's go through a few examples and try to apply all the knowledge from integration. Okay, figure 3 shows a sketch of the curve with equation y is equal to root x. The point at pxy lies on the curve, so this point is equal to xy. The rectangle shown shaded in figure 3 has the height y and width delta x. Calculate limit delta x tends to 0 from the sum of x equals 4 to 9 root x delta x. So that is the same thing as saying if we draw multiple rectangles between x equals 4 and x equals 9, all of them of length delta x, and we sum them up, then what we're essentially doing is we're just trying to find the area under the curve using this rectangle. So that is equal to the area under the curve, y is equal to root x, between x equals 4 and x equals 9. Now that is the same thing as integrating with upper limit 9, lower limit 4, root x dx, because the area function is the same thing as integrating the function between those x values, which is the same thing as integrating between 9 and 4 x to the power of a half, because root x is just x to the power of a half, and we need it in index form before we can integrate. Now when we integrate x to the power of a half, we get x to the power of 3 over 2. X to the power of 3 over 2, and then we do get 1 over 3 over 2 as our factor at the beginning, which is the same thing as 2 over 3. Between 9 and 4, all I have to do now is substitute 9 and 4 in. So let me just go here because I don't have enough space. So 2 over 3, 9 to the power of 3 over 2, minus 2 over 3 times 4 to the power of 3 over 2. Okay, when I substitute these values into my calculator, I get 18 for my first term and 16 over 3 for my second term. 18 take away 16 over 3 is the same thing as 38 over 3. So that would be my answer for the area. Okay, a similar question now. The diagram shows the sketch of the curve with equation y is equal to cube root of x, where x is greater than 0. The area under the curve between x equals 2 and x equals 5 can be thought of as a series of thin strips of height y and delta x. Calculate limit delta x tends to 0. So all we're doing again is a series of rectangles in both directions, so going on endlessly. Calculate limit delta x tends to 0 of the summation of x equals 2 to 5, the cube root of x delta x, giving your answer correct to 4 decimal places. So limit delta x tends to 0 of the summation starting from x equals 2 to 5, cube root of x delta x is the same thing as the area under the curve. Y is equal to cube root of x between x equals 5 and x equals 2, which is the integral from 5 to 2 of cube root of x dx, which is the integral from 5 to 2, if I convert that to index form, is x to the power of a third dx. Now when I integrate it, I raise the power by 1, so I get 4 over x to the power of 4 over 3. 1 divided by 4 over 3 is 3/4, so 3/4 is my factor at the beginning. Upper limit of 5, lower limit of 2. Substitute 5 in first, and then subtract from when you substitute in 2. Now when I put these into my calculator, I don't get nice numbers, so let me just write the numbers down. I get 6.41241 when I substitute in 5. When I substitute 2 in, I get 1.88988. When I subtract them, I get 4.52253. If I round it to 4 significant figures, I get 4.5 4.523. Next question, which is slightly different. Given that the integral from 3k to k of 3x plus 28 dx is equal to 7 and k is greater than 0, calculate the value of k. So that means, so we've got this condition, which means if I separate out the bracket, I get 3k, sorry, the numerator, I get 3x over 8 for the first term, plus 2 over 8, which is just a quarter. I'm just going to write it like this because it's easier to integrate. Must be equal to 7. Now that means when I integrate it, so when I integrate 3x over 8, I get 3x squared over 8 times by half, so it becomes over 16. A quarter integrated will give you really just a quarter x, so it's just, let me just write it as x over 4. And my upper limit is 3k, my lower limit is k is equal to 7. Okay, so now I need to substitute 3k in and then k in. So I just get 3 times 3k squared over 16 minus 3k over 4. Take away from 3 times k squared over 16 plus k over 4 is equal to 7. Which means when I expand this out, I get 3k squared, all squared is 9k squared. So I get 27k squared over 16 minus, oh sorry, there's a plus here. I made a mistake. That's supposed to be a plus, okay. Let me just go back, be very careful. So there's a plus there, so it's a plus. 3k over 4 minus 3k squared over 16 minus k over 4 is equal to 7. If I collect the like terms together, I get 27k squared over 16, take away 3k squared over 16 is 24k squared over 16. 3k over 4 minus k over 4 gives you 2k over 4, which is just k over 2. K over 2, which is equal to 7. If I times through by 16, I end up getting 24k squared plus 16k is equal to 7 times 16, which is 112. If I divide through by 8, because they're all factors of 8, I get 3k squared plus, oh, I made a mistake. I made a mistake here. So I did times by 16. 24k squared over 16 times 16 gives me 24k squared. K over 2 times 16 gives me 8k. And 7 times 112 is 7 times 16 is 112. Okay, so when I divide by 8, I get k. And 112 divided by 8 is equal to 14. Now it looks like quadratic, so I need to make my right hand side, take everything to my left hand side. So 3k squared plus k take away 14 equal to 0. I need to factorize it, so I'm going to go over here. So if I factorize it, I get 3k in one bracket. And then I want a positive k, so I want to take away 2 here and plus 7 here. Because then I get minus 6k plus 7k, which gives me positive k. Which means k is equal to either negative 7 over 3 or k is equal to 2. But remember, as k was greater than 0, which is what I've highlighted in the question, k must be equal to 2. Okay, next question. The curve with the equation y is equal to x squared minus 5x plus 7 cuts the curve with the equation y is equal to half x squared minus 5 over 2x plus 7. The shaded region R is bounded by the curves as shown. Find the exact area of R. So I need to find this point and that point first. Obviously, the first one's x equals 0, but anyway, I need to solve it simultaneously to find the 2 points. So I've got y is equal to, the two equations are y is equal to x squared minus 5x plus 7, and y is equal to half x squared minus 5 over 2x plus 7. Which means if I combine them, because y is the subject of both formulas, I can just equate the right hand sides. So I get x squared minus 5x plus 7 is equal to half x squared minus 5 over 2x plus 7. So I know I can just cross these two out. X squared minus half x squared gives me half x squared, minus 5x plus 5 over 2x is minus 5 over 2x, which is equal to 0. I can times by 2, so I get x squared minus 5x is equal to 0. Now I factorize it, I get x times x minus 5 is equal to 0, which means x equals 0 and x equals 5. So that means there is 0, that is 5. Now it's easier to just integrate as 1, so I need to do area under this curve, which is first one, take away the area under the second curve, which will give me the region in between. Because area under the first curve will also give me this part, but then when I subtract it, then I'll be left with the region that I want. So that means I need to integrate between 5 and 0. So the first equation is area of the curve on top, which is half x squared. So it's half x squared take away 5 over 2x plus 7. Take away the second curve, which is x squared, take away 5x plus 7, all dx. So let's simplify it. Half x squared take away x squared gives me minus a half x squared. Minus 5 over 2x plus 5 over x gives me positive 5 over 2x. And plus 7 minus 7 gives me 0. So now I need to integrate that. So when I integrate this, minus a half x squared becomes x cubed. Minus half divided by 3 gives me minus a sixth. Okay, x becomes x squared. 5 over 2 divided by 2 is 5 over 4. 5 to 0. Substitute each one in, so it's the same thing as minus a 6 times 5 cubed plus 5 over 4 times 5 squared. When I substitute 0 in, I end up getting 0. All I need to do is put the first bracket into my calculator, and I get 125 over 12. Okay, next question. Okay, the figure above shows the graphs of the curves of the equations y equals x squared minus 1 and y is equal to 9 times 1 minus 1 of x squared in bracket. The finite region R is bounded by the two curves in the first quadrant and is shown shaded in the figure above. Determine the exact area of R. So again, because it's one area under curve to subtract another area of a curve, I need to find these 2 points where they intersect. So I need to solve it simultaneously. So y is equal to x squared minus 1 and y is equal to 9 times 1 minus 1 over x squared. I solve it simultaneously, I just need to equate the right hand side. Okay, so I need to multiply out the bracket. So 9 times 1 is 9, 9 times minus 1 over x squared is 9 minus x squared. If I multiply through by x squared, I get x to the power of 4 minus x squared is equal to 9x squared minus 9. Okay, I need to take everything to the left-hand side, so I get x to the power of 4 minus 10x squared plus 9 equals 0. So when I factorize it, I get x squared minus 9 and x squared minus 1, which means either x squared minus 9 equals 0 or x squared minus 1 equals 0. Okay, which means that we get 3 different values, which is x is equal to plus or minus 3 for this case, or x is equal to plus or minus 1. Now we know this is in the positive quadrant, so this is 1, positive x-axis, and that must be 3. So we're integrating between it must be x equals 3 and x equals 1, so we want these ones. Okay, let me not highlight it because that's not my final answer. So that means I need to integrate between 3 and 1. So integrating between 3 and 1, now it's this area under this curve, take away the area under this curve, because that one's below. So it's going to be 9 times 1 minus 1 over x squared, take away x squared minus 1 dx. So if I simplify it, it's the same thing as 9 plus 1, which gives me 10, minus 9 over x squared, which is in the minus 9x to the minus 2, and I get a minus x squared. Now I can integrate it. I get 10x. So I get x to the minus 1 when I increase it. Just leave a bit more space. X to the minus 1. So minus 9 divided by minus 1 gives me positive 9. And the last term is, when you integrate, I get minus a third x to the power of 3. Between 3 and 1. So the first thing I need to do is substitute 3 in. And then I need to subtract from when I substitute 1 in. When I substitute 3 in, I get 24. When I substitute 1 in, I get 18 and 2/3, which means my final answer is 5 and a third. Okay, the next question. The figure above shows the graph of the curve C with equation y is equal to x to the power of 5 over 2 minus 8x. The curve meets the x-axis at the origin and at the point A. The tangent to C at O is denoted by L1 and the tangent to C at A is denoted by L2. The finite region R shown below, shaded in the figure above, is bounded by C, L1 and L2. Determine the area of R. Okay, so the first thing I need to do is find out. I know this is the origin, I need to find A. So in order to find A, I need to equate the equation to 0, because y is equal to 0 at that point. So x to the power of 5 over 2 minus 8x is equal to 0. Which means x to the power of, if I factor out the x, x to the power of, x times x to the power of 3 over 2 gives me 5 over 2 minus 8 equals 0. Which means x equals 0, which we know, which is the first, this one. And we have x to the power of 3 over 2 minus 8 is equal to 0. I rearrange that, I get x to the power of 3 over 2 is equal to 8, which means if I square it, let's cube root it first, so x to the power of a half, I cube root 8, I get 2. Now I need to square it to get x, so is 2 squared, which is equal to 4. So that means A is equal to 4, 0. So I know this is 0, 0, and this is 4, 0. Okay, so let's find out. First, let's find out the area under the curve here, because we need them. So if I want to find out this part, we're integrating between 4 and 0. Now we know that this is below the y-x-axis, so what we're going to get is a negative number. So if we don't get a negative number, we've done something wrong. So I need to integrate x to the power of 5 over 2 minus 8x dx. So when I integrate this, I increase the power, which is 7 over 2. I divide by the increase, which means I get 2 over 7. Okay, x increase the power becomes x squared. Minus 8 divided by 2 is minus 4. So I get minus 4x squared. Integrating between 4 and 0. Which means I get 2 over 7 times 4 to the power of 7 over 2 minus 4 times 4 squared. When I substitute 0 in, I get 0. I put this into my calculator, I get negative 192 over 7. And obviously I change this to a positive number. It's negative because it's below the x-axis. The next thing I need to do is I need to find L1 and L2. So I need to find the equation of L1 and L2. Now because they're tangents, I need to differentiate y to find the gradient of these tangents. at these points. So I'm going through the origin and going through A. So first thing I need to do is dy dx. So 5, when I differentiate, I get 5 over 2 x to the power of 3 over 2 minus 8x becomes minus 8. Okay, so I need to find the gradient at x equals 0. So all I'm doing is substituting 0 into my gradient function, which is equal to minus 8. So therefore, using y minus y1 is equal to m times x minus x1 with gradient with m is equal to negative 8 because the gradient of the tangent, and x1 y1 is equal to 0 0. Then I get y minus 0 is equal to minus 8 times x minus 0, which means y is equal to negative 8x. Y, so L1 is y is equal to negative 8x. Okay, now I need to do the same thing, find the gradient dy dx at a, which is x equals 4, which is 5 over 2 times 4 to the power of 3 over 2, take away 8. If I put that into my calculator, I get 12. So therefore, using y minus y1 is equal to m times x minus x1, with m being 12 and x1 y1 being 4 0, then I get y minus 0 is equal to 12 times x minus 4, which implies y is equal to 12x minus 48. So this is y is equal to 12x minus 48. Now I need to find this point where they intersect, because I'm trying to find the area of the triangle. So I need to find first the point where they intersect. Okay, so if I'm doing that, I'm going to have to go here. Okay, so that means I need to solve it simultaneously. So y is equal to negative 8x and y is equal to 12x minus 48. If I solve it, so I'm solving it simultaneously. I've got minus 8x is equal to 12x minus 48, which means I've got 20x 48 is equal to 48, which means x is equal to 12 over 5. Now that I know my x value of this point, so this point is 12 over 5, I need to find my height. So I need to find my corresponding y value. Okay, which means I just need to substitute into either one. So y is equal to, I'm just going to use the easier one, which is minus 8x, which means minus 8 times 12 over 5, which is equal to minus 96 over 5. So this point is 12 over 5 minus 96 over 5, which means I've got this triangle, which has a height of 96 over 5, because it goes down to the y value of negative 26 over 5. And I've got the top part, which is the base of 4, because this goes from the origin to A, which is 4 0. So the area of this triangle, is equal to half times base, which is 4, times 96 over 5, which gives you a value of 192 over 5. Now the area of R is equal to, if you look at it, it's the area of triangle, take away the yellow part. So it's the area of triangle, take away the yellow part that you just worked out. So it's equal to area of triangle, which is 192 over 5, take away the area of so this one, take away the area of yellow part, which is 192 over 7, which gives us a value of 384 over 35. And that would be your final answer. So you can clearly see, if you want the area of R, you need to do area of triangle, take away the yellow part that we worked out. Okay, last question. Okay, the diagram above shows part of the curve C with equation y is equal to 1 plus 2x minus x squared. And the curve crosses the y-axis at point A. So because we know the constant is 1, that must be 0, 1, okay? The straight line L is normal to C at A. The point B is a point of intersection between C and A. Find the exact area of the finite region bounded by C and L. Okay, so we worked out A. So we just worked out A is 0, 1 because y is equal to 1 plus 2x minus x squared. This 1 tells us the y-intercept. Okay, next thing, because we want to find out the equation of L, let's work out, because it's a equation of a normal, we need to first work out dy dx. So dy dx becomes 2 minus 2x. Okay, we need to find the gradient at A. So dy dx, substitute in the x value of A, which is 0, gives me 2 minus 2 times 0, which is just 2. So this is gradient of tangent. Therefore, gradient of normal is equal to negative reciprocal of this, so negative 1 over 2. Okay, now it goes because it goes through A as well, using y minus y1 is equal to m times x minus x1, with m being minus a half, which is what we worked out, and x1, y1 is 0, 1. We get y minus 1 is equal to minus a half times x minus 0, which implies y minus 1 is equal to minus a half x, which implies y is equal to minus a half x plus 1. So that is L. Y is equal to minus a half x plus 1. Now I need to find B, because if I find the coordinate of B, I'll know what I need to integrate between, what the upper limit and the lower. We already know the lower limit is 0. What would the upper limit be? So I need to solve these two simultaneously. So y is equal to 1 plus 2x minus x squared, which is the equation of the curve. And equation of line L is minus a half x plus 1. So because they both have y as the subject of the formula, I can equate the left-hand side is equal to minus a half x plus 1. Plus 1s can disappear. So I end up getting, if I take everything to the right-hand side, I get x squared minus 2.5x is equal to 0. If I factorize it out, I get x times x minus 2.5x. X times 2 minus 2.5, no x because I factorized it out, is equal to 0, which means x equals 0, which is the first one, which is A, which makes sense, and x is equal to 2.5. So we've got this point, 2.5. Okay, so that means because it's one area going from x equals 0 to 5 over 2, I can do the area of the curve, equation 1, take away the area under the line. So this is 2, because there are no intercepts in between. So it'll work out. So that means I need to integrate between 2.5, so 2.5, prefer writing 2.5 to 0. So the area of under the curve, so it's 1 plus 2x minus x squared, take away area of the area under the line, which is minus a half x plus 1 dx. Now if we simplify this, 2.5 to 0, 1 take away 1 disappears. I get 2x plus half x, which is 2.5x, so 5 over 2x, and then I've got minus x squared. So I'm integrating this. That means when I integrate 5 over 2x, I get x squared. 5 over 2 divided by the increase is 5 over 2 divided by 2, which is 5 over 4. And x squared integrates to minus a third x cubed between 2.5 and 0. think I need to make that 2.5 quite clear. Okay, now I need to substitute 2.5 in first, so 5 over 4 times 2.5 squared, take away a third times 2.5 cubed. When I substitute 0 in, I get 0. If I put that into my calculator, I end up getting 125 over 48, which is correct. Now don't forget, you are allowed to do this because there are no intercepts between A and B. So the curve and the line do not intercept in between A and B. And also, it doesn't matter that some parts are below the x-axis, it still works. So we did go through that in area between curves lesson.